So, hi to all. In today's class, we are going to see about Unit 3, which is about secure communication. So, we have previously covered Unit 1 and Unit 2. Right? We have seen all the cryptographic. Before applying cryptography, we have to apply and see what are the methods available for mitigation for attacks and what are the attacks. That's what we have seen in Unit 1 and Unit 2. Now, we are going to apply some cryptographic algorithms. So, in this Unit 3, there are 15 topics are to be covered. In this video, I'm going to cover the first 3 topics, which is introduction to encryption and cryptography, cryptographic functions, and cryptographic types. Let us first see the difference between encryption and cryptography. So many of us understand or think that both are same, both are interchangeable, but it is not so. Basically, encryption is a component of cryptography, whereas cryptography is the science of secret writing. Right. So initially, how does cryptography started is by the word called or the method called steganography. Right. So which is a science of hiding a secret message inside another. Especially, you take an image, inside that image you hide a message, where a legitimate message that acts as the carrier, so the hidden unseen message will not appear during transit. That's what is the starting process of the cryptography. Whereas encryption is the component of cryptography, and it is concerned with concealing secret messages by obscuring them. So in other terms, encryption converts the plain text into ciphertext. Ciphertext means it's not the scrambled text. Ciphertext means into a undetectable form. Right? We are not normal human being. If they read it out, they cannot able to understand the message. That's what is ciphertext. Behind this encryption, some mathematical formulas or steps are involved. This ciphertext can't be decrypted to its original state without applying the mathematical formulas or the keys. So basically, we use a encryption key for encryption. That means as a key is used. And similarly for decryption, we have one more key. Based on this key types, there are formats available or methods available for encryption. Let us see in the next slide. Before that, we have to understand what is cryptographic functions. Right? These are the 5 confidentiality, integrity, availability, authentication, and non-repudiation of the cryptographic functions. For these functions only, we are going to use this encryption algorithms. So what is confidentiality? Preventing unauthorized access. So encryption will be applied to this. That means 2 persons or 2 peers are communicating among themselves. That message should not be leaked to others. It should not be overheard by others. It should not be eavesdropped by others. So we have to apply some encryption algorithm. That means conversion of that message into ciphertext or in some other form, so that any other third person is not able to read it out. The second method is access control. So we have to say who and all can access the message. So for example, I'm a peer. I want to convey my message or communicate a message to another peer. We both only can access the information. No one else should be able to access it. That's what is confidentiality. The next is integrity. Ensuring the data is unaltered, untampered. For that, we have to use hashing and checksums. Hashing is a methodology or a technique wherein which converts your data into a form so that it cannot be reversed. For example, if I hash out the data or a message into a form, that cannot be reversed at all. Right? Only thing is we should know what is a hash key. If we give that key, then only it will not be converted. Again, we have to apply the same hashing algorithm so that we can get back the original message. That's only the method in your hashing is followed. This will be best way. I will explain in the next slides via an example. And the next is very simple ways using the checksums, which implements the XOR gate. Third one is availability. So keeping the systems and data accessible. Right? So any data, that means nowadays we are using most of our Gmail or any of our major content is available in cloud, right? That cloud at any moment of time. For example, our Gmail, if I want to open in the morning, in the mid of the night, anytime it should be accessible. That data should be available. If it is not available, means the meaning for that is the data which is available in the server is not available. So such situation should not happen. That issue becomes availability. So keeping systems and data inside that accessible is called availability. For that, what the cloud servers do is they go for redundancy or backup. For example, our Gmail account itself, there will be redundancy 3 times. If one cloud server is not accessible, it will be accessible from other servers. So with no cost, our Gmail accounts are made redundant and kept in 3 servers, right? So that we can able to retrieve our data at any moment of time. So this is basically called a CIA triad: confidentiality, C for confidentiality, I for integrity, A for availability. CIA triad. The remaining 2 are authenticity and non-repudiation. Authenticity refers to the characteristics of a communication document or any other data that ensures quality being genuine. Right? We have to authenticate so and so is the person who have sent, or so and so is the person who is the owner of that one. And next is non-repudiation. Non-repudiation means a guarantee. After sending a message or after receiving a message, nobody can say that I have not received, I have not sent. Nobody can deny that one. That's called non-repudiation. So all these are basic cryptographic functions. So we are going to apply encryption algorithms for this only. So as I said previously, encryption can be of few types. The first is symmetric and asymmetric. Then comes your hash, which is for integrity, and this is signature. So what is symmetric and asymmetric? I said that we are going to use some keys for conversion of your plain text to ciphertext, right? It's basically a two-way operation. So one side we have to encrypt, which converts your plain text to ciphertext. Another way we have to decrypt, which converts the ciphertext to plain text. So we have to utilize 2 keys, one side for encryption, other side for decryption. If both keys are the same, right, that's called symmetric cryptography. That means same private key. That's called private key. Right? Private key will be owned by the privacy. That means only by the persons. Peers, we two are communicating, then we should only own that keys. What is asymmetric cryptography is wherein we are going to use 2 different keys. One is private key, another is public key. To make you to better understand the concept, symmetric key is like the house keys. For example, we are living in a home and myself and my I have one key to the door which is available in my home to open it out. And similarly, I give my keys also to my daughter or my son. So one more key they have. Both the keys are the same. So to open the house, only one key is available. Whereas if we go to the bank lockers, there are 2 keys are there, right? Everyone knows about it. One key will be available with us. That's called private key. Another key will be available with the bank person. That's called public key. The 2 locks will be there in the bank lockers. One key will be available with us, which is private key. Another key will be available with them. That's called public key because they own it, right? So to open the lockers first, they will open with the key. That's called the public key. So 2 types of keys are available. This is the example for asymmetric cryptography, right? So basically we have to understand that encryption is a two-way process. One side conversion of plain text to ciphertext, another side conversion of ciphertext to plain text. So a cryptographic algorithm works in combination with a key, a number, word, or phrase to encrypt and decrypt data is the backbone of your cryptographic algorithm. This key is composed of a string of bits. So what is key? How to imagine? You have to imagine that how the key looks. It's basically a string of bits. The larger the key, right, the more number of bits are available in the key, the greater the number of patterns that can be created. Very difficult to break. The cryptographic key is a core part of modern cryptographic operations. But nowadays says that the best cryptographic algorithms is RSA. Even that can be broken because RSA uses a large prime numbers as keys. Based on that, some mathematical operations will be applied. A key will be generated. But even that can be broken if we use quantum computers. So there's a challenge coming at the back of us always when technology develops. So if you see here, the symmetric key cryptography is explained as with a diagram, and it is also known as secret key cryptography, SKC. So both the sender, so remember that myself and my daughter or my son will have the same key. 2 different keys, but same key only. Both the sender and the receiver use the same key to encrypt and decrypt the data. So the main disadvantage is one key only, right? If that key is compromised, then the entire communication can be heard through. That's a problem, right? And one more problem is, how do I transfer the keys? For example, myself and my friend is there, we both want to communicate. How to transfer the key to the end person? That is a big challenge. So if you could see in the diagram, same key is used to encrypt and decrypt the data. So symmetric encryption algorithms are split into stream ciphers, right? Where stream ciphers encrypt the plain text individually, or block ciphers. There are stream ciphers and block ciphers. Stream ciphers, we will be encrypting it bit by bit. Block ciphers, we will be going through block by block. So major block length would be 128 bits. What is the famous algorithms of symmetric encryption are? DES, which is data encryption standard, AES, which is advanced encryption standard, then Rinstall, triple DES, Blowfish, Cas-T5, IDEA, RC2, RC4, RC6, Serpent, and Twofish. These are the famous symmetric key algorithms. Asymmetric cryptography is also known as public key cryptography. Remember, symmetric key is also known as secret key cryptography. Asymmetric is known as public key cryptography. So this has two different keys. As I already told you, for encryption it will be one key, decryption will be another key, right? So two different keys are private key and your public key, right? So we can use this side for encryption. We can use a private key. For decryption, you can use a public key, and goes on. That depends how we are going to use. Whereas, remember the example, best example is bank locker. Bank locker, one key will be available with us, which is my private key. Publicly, they will have, because that bank is a public place, right? That's called public key, which is available with the bank persons. With that, both the keys are with available, then only we can open the locker. So if you could see here, in this case for encryption, they have used public key this side, and for decryption, we have to use a private key. Now see the mathematics behind this. Both the keys are different, but still you lock with one system, you are trying to open with the other key, right? Other system. Basically, it's a mathematics procedure, but still it opens. That's the beauty of asymmetric cryptographic algorithm. So one major problem is it requires more computation power, because public key encryption, to send a symmetric key, we require initially we have to use a public key, and then we have to use a private key. Large number of computations are involved. So especially this approach is used by the SSL protocol, secure socket layer protocol, and nowadays this protocol is replaced by transport layer security. TLS 1.3 is the version used. So in this, the public key can be distributed freely. That's why I told you it will be available with them. Whereas the private key will be available with the secret. That means we only will have the private key. The public key is used to encrypt the secret message or to verify the digital signature of the sender, while the private key is used to decrypt the scrambled message or to create the digital signature. So for verification, we use the public key. For creating a digital signature, we use the private key. So this is basically a message is encrypted. Using this technique can only be decrypted back using the corresponding private public key pair. What is the famous algorithms are? RSA, Diffie-Hellman, digital signature, EI-Gamal, ECDSA, and XTR. These are the algorithms available for asymmetric key. The third thing is cryptographic hash. We should remember that confidentiality, in the CAA triad, confidentiality means encryption. Integrity means hashing. I told you I'll give a better example here. Hashing ensures integrity. Very good example is whenever we create a bank net banking login ID and a password. Login ID is almost our customer ID. Password, once we create, it will be hashed and it will be stored in the rainbow table of wherever the bank servers are there. These rainbow servers, rainbow tables available in the bank servers can be viewed by the bank executives. But the thing is that it will be hashed. It will be converted into a ciphertext. That means it will be hashed and kept. So that if they view also what is the real password, they don't know. And moreover, all the passwords, whatever we give, they say that 15 character, 15 bits, so maximum 15 lines should be there. It should be alphanumeric, and then it should have special characters. All will be converted into fixed size only. So they cannot judge the number of bits available in the password. 15 bits or 8 bits, so they cannot judge, because everything will be converted into fixed size value. That's called as hash value. Right? Whatever input, if the input is 1 bit, if the input is n bit, whatever, it will be converted into fixed size hash value, 256 bit or 512 bit. So hash is obtained by running the data through a hash generator. Every time we hash the same data, same value should come. So the real requirement here is every time we hash the same data, same hash value should be produced. That is where the real algorithm challenge applies here, because when large number of data has been hashed, then in that case, for example, two different values are there, right? So those two different values should end up with two different hashes. Same value will end up with same hash value. This is the requirement for the hash function. If two different values end up with the same hash value, then it will be a collision problem. That should not happen at all. Two different values should end up with two different hash values. Same data, how many times you hash, it should end up with same value only, hash value only. The meaning for that is n number of time you're trying to get into your login net banking through your login ID and password. Every time when you enter the password will be rehashed, again rehashed in the server side. Rehashed value and your password value will be checked. Then rehashed means already they would have hashed your password and then kept in the rainbow table. That's a hash value. Whenever you give in your password, that password also will be hashed again. That value and the stored value in the rainbow table will be checked. Both should be same. Then only you will be a legitimate customer. You will be entering inside your net banking of the respective bank. I hope all of you understand. Again, I'm repeating. All your passwords, whenever you give for the first time, the passwords, whenever you're creating the password for the first time to enter into the net banking, it will be hashed, it will be stored in the rainbow table. Any other time, if you are relogging in, that means again you're relogging in, that time also, when you give the password, it will be hashed again. That hash value should match with the hash value which is available in the rainbow table. If both are same only, you will be allowed inside the net banking login ID, right? This is the basic function of your hashing. So this ensures that integrity. Now, none of the person or any other person try to change the password, try to view the password. Nothing can happen here because it is all hash values. If they try to change, even for example, Sharmila is there. Even Sharmila becomes V Sharmila. One letter I'm changing. That will have a drastic change in the hash value. Right? It's a 256-bit or 512-bit. That will have a drastic change. Not a minimal change. Will have a drastic change in the hash value. Between Sharmila and V Sharmila, if I hash both, you will end up with different types of values. So that is where the challenge in your hashing algorithm. So the receiver may then compute the hash of the data received and compare with the hashes received, and it ensures that no tampering has happened. The famous algorithms for hashing is MD5, which is Message Digest Algorithm 5, SHA-1, SHA-256, even SHA-512 is there. The best secure hash algorithm is the one that has best speed and collision resistant. As we've already informed, collision resistant means two different inputs we are giving, that should end up with two different hash values. Definitely, it should not end up with the same hash value. Even it is going through multiple amounts of data, it should end up with two different hash values only. So what are the basic applications of hashes? Hash values are used extensively during digital forensics, especially when the digital forensic officer goes for the capturing the system. For example, there is a hacker who has performed a crime using a laptop or a computer. The moment the digital forensic officer go to their place, immediately they'll do the RAM capture. After doing the RAM capture, they will convert the RAM capture, whatever they do, they will be having a tool in their USB itself. Via the tool, they'll do a RAM capture. After capturing the RAM, they will immediately convert that into hash, and that hash will be filled in a form. Right, in the form that hash will be filled, and that will be signed by both the officer, digital forensic officer, as well as the hacker who has performed the crime. Both have to sign. Why? Because once you have done it, once you hashed it out, because RAM you have captured, you have hashed. Any other time, if you again do a hash, the same hash should repeat. That means for the forensic officer who has captured the RAM cannot change the data, or any other person who's trying to change the data in between also cannot do it. If they do it out, if they again rehash it out, it will end up with a different hash value. For that reason only, mostly in digital forensics investigations, they use the hashing technique. As I already informed, hashing is also used to store the user credentials, which is passwords, and it is used in management information systems. And hashing can also speed up the process of searching through a database, because searching hash values is faster than searching for a long string names with databases, because basically numbers, it's hexadecimal numbers we are going to use. One piece of information is we have to stop using SHA-1 because Google has already corrected. So SHA-1 is not the best hashing algorithm. If you using that, it can be easily cracked. The next is key exchange algorithms. As I already told you that the challenge for the symmetric key cryptography or as well as the asymmetric key cryptography is we have to first exchange the keys between the two parties, right? Myself and the known party, or if I'm going to transfer my communication to someone else, it is unknown party. How to communicate the keys? What are the methods? So when two parties want to use a symmetric key cryptography, we have to exchange the keys very secretly. In case of public key cryptography, we have to exchange the public keys because private key will be with us only. The public key has to be exchanged in a very trusted way. How to do it out? The methods are Diffie-Hellman key agreement algorithm or RSA key exchange process. So both of these process provides better ways for transferring the keys in a secret way, right? And the Diffie-Hellman key exchange algorithm is used to SSL connection, provides better performance when compared to the RSA algorithm. So this is RSA algorithm. If you could see here, Nihad wants to communicate to Susan. So Nihad uses his private key plus the public key of Susan. Combined together becomes the shared key. NS here is Nihad Susan for encryption. For decryption, they use the Susan's public key plus Nihad's private key. So Susan's private key and Nihad's public key. This is what they use it out. So in this way, they try to make the communication communication very in a secret way or very difficult way to crack it out. So as I already told you, cracking the RSA algorithm is very difficult. It is because the basic mathematics behind RSA algorithm is prime numbers, large prime numbers with combinations of mathematic formulas they use. But the challenge is quantum computers can crack it out. So that's the challenge. So again, I'm repeating, for encryption, we use Nihad wants to communicate to Susan. For encryption, we use private key of Nihad and public key of Susan. And for decryption, we use private key of Susan and public key of Nihad. This is the way the communication happens in RSA. In case of digital signature, is basically digital signature application is, if you could see, the birth certificate or the community certificate is signed by a authority, right? The Tahsildar office authority signs it out, right? That's called digital signature. And even when you want to do your MS in abroad, all your degree certificates, right, they can digitally take it out because the COE office, from the COE office, they will digitally sign your degree certificate and upload in a portal, and the same portal can be opened in the other countries to check the certificates. That's why digital signature signed documents have got value for it. So authentication. So digital signature comes to the word authentication. So if you could see one by one, I tried to cover, right? So CAA concept plus C I covered for encryption, which is confidentiality. I covered for integrity, which is hashing, and for authenticity, it is digital signature. So authentic means it is from the correct person who has authorized that content. That's without any tampering. It has been sent via the portal. Online it is available. That's what is the meaning of digital signature. It is basically equivalent to a handwritten signature or a rubber stamp. But since the numbers, the crowd or the number of people available around the world is more, digitally signing document is much worth or much useful when it is available online rather than going from place to place and getting the signature. This digital signature is based on asymmetric cryptography only. For example, public key and private key. For example, to have your email ID signed, right? First, we need two keys, private and public keys. The signing software, such as the email client like Thunderbird, signing software creates a hash, also called as a message digest, that you're going to sign. The private key is used to then encrypt the hash. This is the method. The result is the digital signature. So finally, the email client appends the digital signature to the email. Now all the data that was hashed has been signed. So this is the diagrammatic explanation for digital signature. So if you can see the person who's sending the data and hashing algorithm is used, private key is used for after the hashing, right? After the hashing, private key is used for encrypting. And then the digitally signed, the document is available. It is sent through the internet. Then digitally signed document is decrypted using the public key, and it will be rehashed. You understand? Here again it will be rehashed for checking whether both hashes are same, right? And then the signature, if both the hashes are same, the signature is valid. Otherwise, the signature is not valid. This is how the digital signature application is used. So if the recipient wants to validate the integrity of the received message, all he or she needs to do is to use the sign as public key to decrypt the hash. Sign as public key, right? Sign as public key to decrypt the hash. So publicly, if a key, the meaning for that is a key which is available publicly. For example, if you want to check your date of birth, right? Date of birth, that means the birth certificate. Date of birth is known. Via that you can able to download and see whatever is available data. That is what is your public key. You have to understand the concept here, right? So if the decrypted hash matches the value of the hash generated by the recipient software for the same data set, the message is authentic. That's how it gets authenticated. If the two hashes doesn't match, this means that either the message has been tampered with during transit, or the signature was created using a private key that doesn't correspond to the public key. So the public and the private key matching should happen here. So if you could see the diagram, they are using a first hashing. After hashing, they are using a private key. Then they are sending over the data. That is digital signed document. Then the digital signed document is decrypted using the public key. If you do that, also same hash should be produced. That's a challenge, right? If that produced, only that that digitally signed document is authenticated. Otherwise, it is not. The verifier cannot verify it out. So we should able to understand the difference between digital signature and e-signature. E-signature, for example, if you want to sign a copyright form, what we do, we use PDF software. We open the document by a PDF. There's a sign is there, e-sign is there. We put our sign, right? That's e-signature. That e-signature and digital signature is not the same. E-signature is just to authenticate our sign, and then we agree that we are signing for the document. But digital signature is something which applies at the background, some algorithm, right? As I shown you, this is the algorithm applied. E-signature doesn't apply any algorithm, right? They each, for example, IEEE copyright form, they have their own signature by creating a link, and via that link they will mention all the agreements and they will ask us to sign. That's called e-signature. That is different from the digital signature. Thank you. This is how the cryptographic algorithms has been explained in this video. All of us should know the importance of these algorithms, because every day we actually use these algorithms. When you open your computer, when you open your website, right, any of the website, all these digital signatures are happening at the background. When you use your router, AES algorithm is running at the background, right, which is a symmetric algorithm. So both your symmetric key as well as your asymmetric key, both algorithms has been used at the background. So that is what we have to be having the clarity. So these CIA and then this 5 components, right? It's not the cryptographic functions we are not using on a daily basis, right? It's not like that. Every day, whatever we perform in the system, right, at the background of it, these are the 5 components which takes the major place. Right? If I say confidentiality, I'm opening a website, I'm performing some operations on it, right? I'm sending a message or downloading a message, whatever I'm doing it out, right? That is based on the confidentiality between myself and the website. Similarly, integrity. When I store some data, when I want to send some data to the bank, for example, the password has to be stored in the bank net banking servers, right? In that case, I'm going to use hashing. Availability in terms of cloud service. And I'm trying to access the cloud service, data should be available for me any amount of time. For example, Gmail is the best example. It should be available. So all these are the basic concepts we are using on a daily, day to date or moment to moment. Whenever you open our laptops, these are the 5 components comes to the picture. The last is authenticity. As I said, any digital signed document if we want to use, we have to use this authenticity component. And finally, non-repudiation. After sending a message, after sending an email, can anybody deny that email I have not sent? It's not possible, right? If it's sent from your email, it is you only have sent. You are responsible for disclosing your password, your Gmail account to other persons. That's your responsibility. You cannot deny that I have not sent. So whenever we are handling with Gmail accounts in our mobile, be careful. Do not give no options for your friends or others to use your Gmail accounts, right? It is highly dangerous. They may send a mail using your email ID, and then later on you cannot deny that I have not sent. So it's better that you use your Gmail only in your devices, your laptop, your phones. Do not give access of your Gmail account to others. Always be be careful, or be attentive that your which all devices your Gmail account is working on. For example, if you go log into your Gmail account settings, you can able to see your Gmail is active in on which all devices. That devices should be yours. That part you have to ensure. Okay. Thank you all.